Bismillahirrahmanirrahim. Assalamu alaikum. My name is Tamsil Sajid and I am from the Department of BS Biotechnology. The topic which I am going to present is infrared spectroscopy. As my other fellows have told you about what is infrared spectroscopy, its principle, its instrumentations and its working. Now I'm going to tell you about the applications of infrared spectroscopy. So let's talk about the applications. First of all, identification of the substances. It is basically used to compare substances, and its fingerprint region as it is basically it has region fingerprint region, that is absorption band is 1200 to 600 per centimeter. Large number of absorption band is observed in infrared spectra of organic molecules, and it is probability that any two compounds will produce identical spectra is almost zero. So if two compounds have identical infrared spectra, then both of them must be sample of the same substances. The first criteria that sample must be tested in identical conditions like physical taste, state, temperature and solvents. But the big disadvantage is that enantiomers can't be distinguished. It is basically we use it to establish whether given sample of organic substance is identical with another or not. Okay, the second one is that the determination of the molecular structure and detection of the impurities. It is used along with other spectroscopic techniques. It is identification is done based on the position of absorption bands in the spectrum. Absence of a band at particular group indicates absence of the bands in that group compound. Infrared spectroscopy of the test sample to be determined is compared with standard compound. If any additional peak is observed, then it means that there is any impurity that is present in that compound. Okay, studying progress of the reaction. Studying progress, observing the rate of disappearance of characteristic absorption band on reactants, rate of increasing absorption band in product of a particular product, like for example oxygen hydrogen bond has 3600 to 3650 per centimeter, and carbon double bond oxygen has 1680 to 1760 per centimeter. It also measures the degree of polymerization in the compound, and it also measures the molecular structure. That identification is based on position of absorption of bands in spectrum. Absence of bands of the particular group indicates absence of that group. Isomerism in organic compounds. The infrared spectrum of an organic compound with its complexity of the bands provides an excellent fingerprint of compounds. It can be used to identify a certain common groups such as carbonyl and amino. Geometric isomerism. If we talk about isomerism in organic chemistry, then geometric isomerism like trans isomers gives simpler spectrum than is due to its symmetry. Conformers like rotational isomers identifies with high resolution of infrared spectrometers, like for example ethanol. Its normal hydroxyl group is 36 per centimeter, but its weak band is 36 22 per centimeter. If we talk about tautomerism, then we find that it existence of two or more chemical compounds capable of interconversions, usually by exchanging a hydrogen atoms between two atoms. For example, thiocarboxylic acid. As you can see the structure of the thiocarboxylic acid. Okay, applications of infrared spectroscopy to inorganic complexes. First of all, we talk about what are difficulties that we find. First of all, high mode of vibration. Since they contains more than 5 atoms, hence minimum 10 modes of vibrations. So it also contains low symmetry of complexes due to formation of ligands and polynuclear complexes, formation of gillette, large number of new bands appear. Assumptions. Complex formation affects only the vibration of the ligand slightly. Vibrations do not undergo coupling with other vibration of another ligand. When ligand is coordinated with other atoms, it will not change the symmetry of ligand. Shape of symmetry of a molecule, like nitrogen dioxide. If it linear, then it forms two bands, and if it bands, then it forms three bonds. But its actual spectrum shows three peaks, like 750, 1320 and 1616 per centimeter. Similarly, infrared spectroscopy used to determine the structure of the HCF2, HCF4 and HCF6. These forms linear, square linear and octahedral shapes respectively. Identification of the functional group and functional group isomers. Functional group that are 2-methyl-2-propanol, its absorption band is 3500 to 3100 per centimeter, and 2-butanone 1700 per centimeter. And functional group isomeris is diethyl ether and ethanol, and its hydroxyl absorption band is 3500 to 3100 per centimeter. Infrared spectroscopy in industry. Industries determines the impurities in raw materials to ensure the product quality. For quality control checks to determine the percent of required product, identification of the material made in industrial research labs, analysis of petroleum, oil and grease content. Analysis of petroleum, oil and grease content. These contains carbon-hydrogen bonds and its absorptions at 3100 to 2700 per centimeter. Freons that are called fluorocarbons and its absorption band is 113, and it don't contains carbon-hydrogen bond. Thus, quantity of oil and grease in freons is determined by measuring carbon-hydrogen absorption at 2930 per centimeter. Protein quantitation. Infrared spectroscopy is one of the most well-established techniques for the analysis of protein structure. In protein, amino acids are covalently linked to the peptide bonds. By measuring amide bonds in protein chains, we can accurately quantify an intrinsic component of every protein. Amide A. As you can see in the graph, like amide A have 36 per centimeter is with more than 95% due to the nitrogen hydrogen stretching vibration, and amide 1 that is present at 1600 to 1700 per centimeter, and it is most intense absorption band in stretching vibration of carbon double bond like 70 to 85%, and carbon nitrogen that is 10 to 20% present. Non-intensive blood glucose monitoring. Near-infrared spectroscopy is used to measure glucose across the air lobe. Amount of the near-infrared light is passing through the air lobe depends on their amount of blood glucose in that region. The air lobe was chosen due to the absence of bone tissues and also because of its relatively small thickness. Infrared spectroscopy in lipids. The structure conformation and dynamic properties of the lipids in lamellar phases can be using FTIR and optical probe technique. Recent advance in the analysis of FTIR spectra of lipids and use of the isotonic labeling technique, it provides new insight into the conformational behavior of lipids chain in different lamellar phases and have made it possible to distinguish different hydration sites in the lipid head groups. These techniques have been extended to study lipid mixtures and to help determine whether microdomain formation is possible in liquid crystalline lamellar system. FTIR are studies for gain information on membrane heterogeneity and have improved the understanding of the membrane behavior. In forensic, much of the evidence that is left at a crime scene consists of organic compounds. Infrared spectroscopy is useful in forensic investigations. Paint, ink, sweat, fuels, and hair are all examples of the substances that can be identified in this way. Over time, the technology has also been refined so that the sample sizes can be very small and portable, like infrared equipments can be taken directly to a scene for on-site analysis. Infrared does not alter the evidence since very small amount of energies are applied. Infrared also find about fibers. It is often in crime scene and it even possible to determine if the hair has trace of the hairspray with infrared sample preparation. Other applications of infrared spectroscopy. Here are the other applications of the infrared spectroscopy. The first application is determination of unknowingly contamination in industry using FTIR. The second one is determination of the cell walls of mutant and wild type plant varieties using FTIR. Biomedical studies of the human hair to identify disease states. identify odor and taste components of the food, determine the atmospheric pollutants for the atmosphere, and examination of all painting. Limitations of IR spectroscopy. Not possible to analyze the molecular weight of any substance. Spectra narrowness makes the measurement of the absorbance using the slit width and the setting of the wavelength. It does not provide information about the relative location of the functional group of a molecule. Thank you so much. That's all from my side.